Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 40 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find the graph that best represents this exponential function here, f of x equals 2 times 5 to the x power. So let's analyze our standard form here to make sure we know what we're dealing with, because that's going to give us our first clue. And so what do we mean by this a right here? Well, it could be multiple things. If we're dealing with investment and compound interest, it's the principal. We can also simply call it the starting or the initial amounts if we have a word problem with maybe population growth and they tell you how many certain creatures there were, bacteria there were to begin with. But most importantly, we can say this a term is going to be your y-intercept. It's where the graph crosses the y-axis when x equals 0. Now, how do we know that? Well, let's just plug 0 in here. A times b to the 0. Well, anything to the 0 power is simply 1. So that's a times 1, which means when y equals 0, when x equals 0, y equals a. So I've got this 2 right here. That's my y-intercept. So we can take a look at some of these. Now the scale is kind of off here, but yeah, this F looks like a possibility. G looks like a possibility. Look at this H though. It's got the y-intercept at 10. It's not at 10. This A term is my y-intercept, so see, we can already get rid of that. And then look at J. Once again, y-intercept is at 5. Y-intercept needs to be at 2. So I've already eliminated H and J just by recognizing that that A term is going to be your y-intercept. Now, what is this B term? This B term is going to be your rate. It's going to be a growth rate if it is greater than 1. So in this case, we do have a growth rate because it's greater than 1. It's going to be a decay rate if it is less than 1. This is not a decay rate. So a decay rate is going to look something like this. It's going to be a function that kind of looks like this, kind of gets closer that way. So a growth rate is going to be like what we see in F and G. It's going to increase when you're moving from left to right. All right, that's kind of what it's going to look like. So we're between F and G. So how do we choose between those two? Well, look, we could just go old school. Let's just plug numbers in, right? So we've got x. We've got f of x. Let's just plug them in. So I've got f of x equals 2 times 5 to the x. Okay, so when x is 0, right, we did all that work. F of x is 2, so we're good there. What happens when x is 1? Okay, so let me see. F of x equals 2 times 5 to the 1. Okay, so that's just going to be 2 times 5, because that's just, 5 times 1. So there we go, 10. Okay, so f of x equals 10. So let's see if we can plot 110. 110 looks good right there. Look at that g right there, 1,5. So that is a problem because we need 110. So I'm looking like f is the only one left. Let's see what happens when x equals 2, because we don't even have, well, we do have a 2. It's up there. Okay. So f of x equals 2 times 5 squared. That's going to be 2 times 25. That's going to be 50. And yep, I've got that 250 right there. All right, so yep, that is looking good. 2 times 5. All right, so my answer here is going to be F.